Hey everyone, so today we're going to talk about being able to solve inequalities using multiplication and division. So we're going to start with our first step here. So our first step is going to be to create a t-chart similar to what we do for solving with addition and subtraction. You always want to create a t-chart, and so we do that by dropping a dashed line down our inequality symbol. Remember, two purposes here. It's to make sure whatever you do on one side, you do on the other side. So it acts as a line of symmetry, but it also acts as a placeholder for your less than or equal to symbol. Then in our second step, we want to identify the operation being performed to the variable. So now we can look at this variable here, and I'm going to circle it in green. So now we can look at this variable here, and we can ask ourselves this super important question. We can say, what operation is being performed to this variable? And hopefully we notice that this variable is being divided by 5. And then we got to ask ourselves, okay, to solve this inequality, that means we need to perform the opposite operation. So the opposite operation of division is multiplication. And then whatever we do on this side, or on the left side, we need to do on the right side. So we're going to multiply on both sides, and we're going to multiply both sides by 5. And we're going to multiply it by pretty much the denominator of this fraction. So that way, if you were to multiply 5, and I'll do this up here as like a side note for you, 5 times x divided by 5. If you notice, if we created this 5 as a fraction out of 1, we could say that, okay, this would equal, well, we notice that 5 and 5, we can factor out a 5 here and simplify it. So 5 divided by 5 is 1, 5 divided by 5 is 1, and then that's going to leave us with just x. And that's the point. We want just the variable. The whole point of solving inequalities is solving for the variable, so we want the variable alone on one side. And so we notice that by multiplying both sides by 5, we get that variable alone on the left side. Then we can bring down the inequality symbol to less than or equal to sign. This acts as a placeholder for that symbol, so we're going to put it right along this line here. I'm going to fix that. It doesn't look as good as I want it to. And so now we're going to get that negative 3 times 5 is negative 15. And so we notice here that that x is less than or greater than negative 15. And so my final step here is going to be to graph. And so the way we graph is we graph on a number line. So I'm going to create a number line here. So there it is. And then in the middle, we're going to put negative 15. Then when it comes to the right, that means we're approaching 0. So our numbers are going to get bigger. And then as we move to the left, we're getting further away from 0, which means our numbers are getting smaller. We know that we need to have a closed circle because it's a less than or greater than symbol. And then we need to shade on the appropriate side. So the way we tell which side to shade is we plug in a value. Let's call negative 14 the one I want to plug in. So then I ask myself this question: is negative 14 less than or equal to negative 15? And negative 14 is not less than or equal to negative 15, which means I need to shade in the left side. I don't want to shade in the side that negative 14 is on because we just proved that it wasn't a solution. So I need to be able to shade the other side. So I'm going to shade this side here. And that is how you graph and solve one-step inequalities.